Hey guys, and welcome back to another video on the channel. In today's video we're going to be tackling a problem we have taken a look at before on the channel, but I've made a little bit of errors with some of the assumptions, but I'll be retaking a look at. So if you integrate this particular function here at a certain Chinese school, I believe it gives you a specific Wi-Fi password. This is just some of the stuff I've heard in the comments at some, I'm not sure if it was a school or some sort of like university, but I remember reading one of the comments and it was mentioned it was something in China or something like that. But anyway, if you integrate this pretty much, it's going to give you the Wi-Fi password for a specific place anyway. So what we can do to make this easier is we can break the integral up by distributing this factor to all of these guys here. So we're going to have -2 to 2, and then we'll have x cubed cos of x on 2 multiplied by this, so square root of 4 minus x squared plus square root of 4 minus x squared all on 2 dx. Okay. Now we can break this integral up because of this plus sign here, so we can rewrite it as two separate integrals. So the integral between -2 and 2, and x cubed and cos of x over 2 square root of 4 minus x squared dx plus the integral of -2 to 2 of square root of 4 minus x squared on 2. Yeah, ignore that notification, that's just for math tutoring. That was a bit later. But anyway, so let's take a look at this stuff here. So what we have here technically is a semicircle. So if we were to plot this function on a graph, this is the equation for a semicircle. What if I replace this with y instead? It might be more obvious then. Square both sides, and then you have y squared is equal to 4 minus x squared. Move the x squared over, and you have y squared plus x squared equals 4. Plot that on a graph, and that gives you pretty much a circle with a radius of 2. Because the general formula for a circle is y squared plus x squared equals r squared. Okay, so if you square root 4, it'll give you the radius, so radius is 2. However, this is only the top half of a circle, because when you take the square root of both sides, you need to do a plus or minus here. However, there's only a plus, so we can only assume it's half the circle. So what we have in this scenario here is just the top half of this circle here. Okay, so this is from -2 to 2, and yeah, that's about it there. So rather than actually integrating this, we can see it's got symmetrical bounds. So what we can technically do is replace this integral here. Well, we can take the 2 out the front if we wanted to. So we can go take, well, not the 2, the half, you know what I mean. Move that there, take the half out the front door, and then integrate this is the same as pretty much, so this integral here is the same as just pretty much the area of half a circle. So the area of a circle is pi r squared, and we want half that circle, so divide by 2. The radius in this case is 2, so we have area is pi 2 squared on 2, so we have pi 4 on 2, so we have 2 pi. So that would replace this entire integrand here pretty much. Okay, so if we put the 2 pi there, we pretty much have a half times by 2 pi. Okay, so a half times 2 pi is just pi. So that entire bit just turned into pi. Now let's take a look at this other bit here. So what I made wrong in the last video was about the idea of an odd function being rotated 180 degrees. An odd function is pretty much if you input a number that's negative, so if you have f of -x, that's the same as that output being just the negative of that pretty much. So what I mean by this is pretty much if you go sine of -pi on 2, that's the same as negative sine pi on 2. Okay. Same if you had, let's say, another odd function like a cubic. If you had -5 cubed, that's the same as negative times 5 cubed. Because if you cube a negative number, it's still going to be negative. Because it's an odd function. So this is the definition of an odd function. And now an even function is pretty much, if you input a negative value, that's the same as inputting the positive value of it. So an even function is when you go f of negative x is the same as going f of x pretty much. So what I mean by that is if you have, let's say, the cos curve, for example, and let's say this is negative pi on 4 and this is pi on 4, they are going to share the same value there pretty much, which is, I believe, 1 on root 2. Okay, so cos of negative pi on 4 is the same as cos of pi on 4. Now you're probably wondering, why do we need this stuff here? Well, it's going to be important when taking a look at this integral here and this idea here about inputs and outputs. So I'm going to get rid of all that now, and pretty much we're going to break this apart without doing any calculus really. So I'll move the pi where this integral was, and we'll write it as pi. So if you integrate an odd function over symmetrical bounds, the integral will be 0. What I mean by that is, let's say we had our sine function again, except just from pi to negative pi. If you were to integrate negative pi to pi of sine x, you should get 0. Even though its area isn't 0, the integral itself is 0. The reason why is because this here, this area, is the exact same size as this area, except this one is negative. Because if you were to work it out, from negative pi to 0 of sine x, if you integrate sine x, you're going to get negative cos x. Oh, that's a terrible cos. Negative cos x. If you put in 0, minus cos of negative pi on 2, cos of pi is negative 1. So you'll have negative 1, because cos of 0 is 1, so negative 1 minus cos of negative shift pi, which is negative 1. So the whole area here would be negative 2. And if you were to do the same thing here from 0 to pi, you would get 2. And when you add those two together, they cancel out pretty much. So that is also very important when taking a look at this integral here as well. Okay. So we've got to work out whether this entire function here, because it's a product of function, we've got to work out whether it's odd or even. That's an odd function. That's an even function, and that is also an even function. So if you have an even function times an even function, it gives you, so I'm just going to write e for even rather than writing it out every time. So if you have an even times an even, it gives you another even. If you have an even times an odd, it gives you an odd. And if you have an odd times an odd, it gives you an even. So we have an odd, an even, and an even. Even times even is an even function, so that whole thing's an even function, but the even times the odd is an odd, and you're integrating over symmetrical bounds, so this integral here will be 0. So the answer to this integral here, to give you the Wi-Fi password, will be pi. So the first 10 digits of pi will be your Wi-Fi password. I hope you enjoyed this remake of this video. If you want to go check out the original, the link is in the description, but otherwise, hopefully you did enjoy it and you learned something.